Hello everyone, welcome to Lazy Man's Hardware, and today we'll be discussing about Karnaugh Map or the kmap. This is one of the basic concepts that you'll be using in this course called digital design or digital electronics, whatever it is for you. So this is one of the most common and the very basic concept in this course, and today we'll be taking a look at it. So Karnaugh Map, it's basically is used in two cases, which is SOP and POS. And SOP basically stands for sum of products, and POS basically stands for product of sum. Today we'll be looking at the sum of product case. I'll be also doing another video for POS. So let's get started. So we use Karnaugh maps for simplifying the Boolean equations that we get in the questions. So in this Karnaugh map, so we basically form some kind of groups with the given minterms, which is exactly what we'll be doing now. And for the grouping, we have a certain set of criteria. So we consider duals, or in simple terms, we basically round off two ones or zeros, which are basically next to each other. And the second criteria is quads, or we basically round off a certain set of 4 elements or main terms in the kmap, which are basically attached or adjacent to each other. Similarly, we have octal, which is exactly the same as the ones I said before, but we'll be considering 8 minterms. Now let us look at a question. So here we have a question for kmap, and what we are basically asked to do is we are supposed to simplify this equation and minimize it using a kmap. So what we have here is a SOP equation, and how can we identify if it's an SOP or PS? We just have to look at the symbol. So if it is sigma, it's SOP. If it has a pi, it's PS. And in SOP, we basically describe the minterms with ones, and in POS, we describe it as zeros. I'll be covering the POS part later in another video. So let us look at the SOP terms now. So what we have here, these are the minterms. So this is what we'll be substituting, and as I already said, if we have a sigma, we need to substitute 1. So where do we actually substitute? I can't see anything, right? So what we are going to do is we are just going to give some order to this table kmap. So follow with me, try to do it along with me. So first you need to draw 16 cells, because the highest number of term here is 11, which is so basically there are different types of variable kmaps, kmaps. So there's a 2 variable type, which is basically extends to 0 and 1, and 3 variable which extends around to 0 to 8, 0 to 7, and 4 variable which extends to 0 to 15, and the maximum term here is 11, which falls under 4 variable kmap. So we need to make 16 cells for this. Now let us mark the cells. So start with me. 0, 1, 3, 2. I think you got the gist of it. So what we are basically doing is we are alternating the numbering in here in these positions, and follow with me, it gets even weirder. 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. So I think you observed some kind of trend. So basically in here we basically swap the positions, like the second one, the last term comes first, and so you basically can see some swapping. And in the 4th cell you can basically see that we basically swap these things out. So this is how we exactly write a kmap. This is our positioning for 4 variable kmap. And let us actually start adding the minterms. So what we have here is the function variables. We have a, b, c, and d. So let us mark the points a, b, c, and d. Where do we do it? Let us mark it here. So as you can see, I have marked some binary numbers here. So what we need to do is we need to write them in our variables in the binary form. So not binary form, exactly variable form. So this side we have cd, so c bar, d bar, and c bar, d, CD, C, D bar. Similarly, here we have A bar, B bar, A bar B, A B, A B bar. So we got those, right? Now let us actually substitute the minterms. Now, so I think I already told you before that we need to substitute once. So let us substitute the ones. And we already so what this means to minterms translate to is these are the positions where we actually have to keep ones. So let us get started. So we have to keep one at 0th position. Let's do that, and one at first position, third, second, fourth, sixth, 8th, 9th, 10th, 11th. Okay, so we got the we managed to write the minterms of this kmap, and this is how we actually fill the kmap. I think you got the gist. Now what we need to do is we need to do the grouping, and as I already told you, we have three criteria for the grouping: dual, quad, and eights. And in every grouping method, we need to take the maximum. We need to group the maximum number of minterms possible. So let us look at the minterms right now. So we are seeing a lot of common elements in this adjacent. They are adjacent to one another. I mean, you can see 1 1 1 1. They are all adjacent to each other, so we can put them under one group, I guess. But no, look down, there's another set of ones, 1 1 1 1. So you basically can't keep quad. So what exactly happens here is this is an extension. So the kmap doesn't end here, it actually starts. Both of these two parts are connected. So instead of forming two quads, we need to form one octal. So what I'm going to do is I'm going to group all these. They're all one group. Sorry for this. And now similarly, I think you've noticed some pattern. We group these two edges, and both of these don't have anything in common because both of these groups are already they're already grouped, and we cannot make common groups again. So what we are going to do is we are going to apply the same concept. So this is, I already told you, this is not the end, not the place where kmap ends. It basically connects to the other end of the kmap. So both of these are adjacent. So similarly, both of these are also adjacent. So they form one dual. So that's it. We form the grouping. And now let us form the SOP equation. So we have two groupings right now. So let us consider this is as group 1. And in group 1, what we basically got here is we got this mapping and this mapping. And the stuff we have in common here is AB, because they're both on the same cell, same direction. And AB is common to both of them. A bar B actually. A bar B is common to both of them. So write A bar B. And now compare the columns. And you can basically see that this is C and this is C. And we can see that this term D bar is common in both of them. As already told you, it extends to here. So both of these are common in D bar is common in both of these cells. So mark D bar. So we got the first part of the grouping, and the second part, the octal one, we just have to do an evaluation. So what do we have here in common? So look at the row wise. I think nothing is common in here. Everything is separate. Now let us look at the rows. So now we basically I already told you this, both of this stuff is common. They are both connected to each other. So if we basically look at the minterms here, you can basically notice that this B bar and this B bar are both in common, but the A bar and A are not in common. So we just have to make another group, and group 2 we have B bar as common. Now the SOP equation, is basically A bar, B, D bar and B bar. So this is our final SOP expression. So I hope you understood something. Pardon me for this. This is my first video, and pardon me for if I made any mistakes. Thank you for watching.